Hi guys, this is David Villar, and in this video we're going to summarize the case that was presented to you of an intoxication in feedlot cattle by monensin, in which the farmer ended up losing hundreds of animals as an unfortunate incident that took place in Kansas. It may be quite interesting from a toxicological standpoint, but I bet the farmer could probably care less about that. So let's give a quick review, saying that ionophores like monensin are antibiotics that are exclusively used in food animals as growth promoters, coccidiostats, and to prevent acidosis and bloat. In cattle, feeding monensin markedly changes the proportions of volatile fatty acids in the rumen, such that there is less acetic acid, butyric acid, and this is accompanied by an increase in propionic acid, which is the most efficiently utilized of all the ruminal fatty acids. On this slide, we can see that propionic acid results in proportionally more production of glucose compared to acetic acid and butyric acid when it reaches the liver. So the more propionic acid is being produced in the rumen by feeding monensin, the more efficiency in terms of getting more groceries out of those nutrients. Now, you do not want to exceed the level of 30 parts per million in the diet, because if you reach 100 parts per million, you're entering into the toxic range for cattle. If you look at the table below, there is a very wide variation in susceptibility between species, with cattle being the most resistant after chickens, and horses being the most susceptible. So this is one reason why you will see quite a few cases in horses. Companies that make feeds for cattle and horses sometimes made mistakes in labeling, or switching one feed intended for one species to another. Now, the case that we're going to see is not because of mixing errors, but because of drug interaction. Monensin was being fed at the same time as an antibiotic macrolide, which interferes with its biotransformation in the liver. We're not going to repeat everything that we said in the previous video. This was published in the Journal of Veterinary Diagnostic Investigation in 1999 by the group of Dr. Ohimi. It took place in 2 feedlots in the state of Kansas. One feedlot ended up losing 562 animals out of 988, and the other lost 50 out of 500 animals. Both feedlots had in common that they received shipments of dried distillers' grains from the same source at the same time. And the animals started dying as soon as 3 days after being fed dried distillers' grains. And within 12 days, one of those feedlots had lost 415 animals. In a case like this one, you start rapidly doing necropsies based on the gross pathology and histopath. You come up with a list of preliminary differentials to what may be going on. And what they found is that the heart was the main organ affected, and the lesions in other organs were secondary to what was taking place in the heart. For example, the presence of interlobular and lung edema, which is what we see here on the left image, was developing because the heart was unable to pump blood back from the lungs, and basically fluid was accumulating in those perivascular spaces and alveolar spaces. And the same was happening in the liver. As you can see, the liver was enlarged with round edges, and the gallbladder wall was also thickened and filled with edema fluid. As we said, the major organ affected was the heart. We can see large areas of myocardial paleness in those ventricular walls, together with areas of multifocal hemorrhage. And the other organ that was also affected was the skeletal muscle, with similar type lesions. And when they look at those fibers under the microscope, they could tell that they were necrotic and degenerate. So because monensin was in the differential list, they measured how much was being fed, and they found that concentrations were actually within the acceptable levels of 30 parts per million. But because this was such a high-profile case, they did gas chromatography and mass spectroscopy and high-performance chromatography altogether, which allows to detect for thousands of chemicals at the same time. And they came up with erythromycin, and further analysis revealed concentrations between 50 and 1,500 parts per million in different parts of the dried distillers' grains. And another thing they did was to demonstrate that the distillers' grains was the culprit, was a feeding trial. They did two groups of 3 animals each. One was being fed distillers' grains and silage alone, and another group was supplemented with the trace mineral mix that contained monensin. And as we can see, the feed consumption was equal at 120 pounds per day until day 4. And then consumption decreased in the group receiving monensin and dried distillers' grains, and all the animals died by day 8. And the animals that only received dried distillers' grain had normal feed consumption on all the time, and they didn't develop any signs. So when they did necropsy on those animals with the monensin and the dried distillers' grains, the lesions were identical to the ones that we just described earlier. If the acute incident was not enough for the farmer, he was also left with some animals that had a chronic heart condition. As we said, the heart is one of those organs that is not capable of regenerating. And on this slide we see the image of one of those animals that was a poor doer. It was not gaining weight after 6 weeks of the incident, and it was put down. And obviously he had scars throughout the heart, and that's what we see on this image here. So if we were to conclude this study in a few sentences, we could say that the interaction between monensin and erythromycin in the distillers' grains was responsible for the death of those cattle. As we mentioned earlier, erythromycin is known to prevent the biotransformation of monensin in the liver, and by doing so, monensin will bypass the liver and get into the systemic circulation, which at therapeutic concentrations should not happen. As we saw, the main target organ is the heart, and that explains the rapid death of the animals in just a matter of a few days from the exposure. And finally, because the heart is also the organ affected, apart from the acute toxicosis, animals were left with a long-lasting permanent heart insufficiency, and that undermined their recovery. So I hope this case was of your interest. This is the final slide. So take care, guys, and until next one, bye-bye for now.